with this rational functions unit is to get to where we're solving rational equations. So the last time we did a lesson, and it's what your assignment was over yesterday, we multiplied and divided, and you don't need a common denominator when you multiply and divide fractions. It's just pretty straightforward. Today we're gonna add and subtract, but the dilemma with adding and subtracting fractions is you gotta have a common denominator. So these two I started us off with. Let me get my marker caught up with us. Come on. Sure, where'd it go?
I almost thought that we were multiplying 7.
Oh, look at that.
Oh, I almost thought we were multiplying those two equations because your mouse was right in between.
Oh, it looked like a little dot.
Yeah.
Stuff that's not working right.
Is it dead?
Well, I just had it charging. Don't know why it's doing that. Well, let's just turn that dude off and do up there. So, when you have the common denominator, you remember from your old school fraction days, you just keep that denominator and do whatever the sign says to the things on top. So 4x, common denominator, check. So we're just going to add, since it's an addition problem, add the things on top. So pretty straightforward there, right? Okay, over here, common denominator, check. So you keep that denominator, and then you just do what the sign says to the things on top. Now the deal here, you can't really combine that. What's 2x minus 5? I don't know. It's just 2x minus 5. So you just stop like that. Okay? Now, life would be fabulous if they were all like that. So what do you think's fixing to happen now?
They won't be like that.
They're gonna have to make it common.
Right. They're not going to have a common denominator, and we're going to have to find it. So
That's a go.
here we go. Let's get my book up here since I got to stand in front of you.
I probably won't need a calculator, do you?
Not really, no. Not really on this. Okay, so we got 7 over 9x squared plus x over 3x squared plus 3x. Now the most difficult part out of this, and it's not really going to be that hard, it's just going to be kind of different. But the most difficult part is going to be finding the common denominator. So our plan of attack, because obviously they're not the same right now. So our plan of attack when we find the common denominator is still going to have to deal with factoring. If there's something that can be factored, we want to do that, because then it's easy to see if one of the denominators needs a part. Like, think about it as taking your bicycle apart, and we got 2 bicycles that are apart. Well, over here there's 3 tires, and over here there's just 1 tire. So we don't need to put all the bicycles together. We just need to move that part that it needs, that tire. And so that's going to be our goal here. We might not need to put all of the denominators on both sides. It just might need a part. So to see what part it needs, we're going to factor them. So the 9x squared is already factored. So I can't do anything to that. But here I've got a GCF. What GCF could I take out of this? 3x. Very good. So if we divide that by 3x, it was a 3x squared, we divided by 3x, so there's an x left. It was a 3x, we divided by 3x, so there's just a 1 left. Okay? So this is the same as that. Alright, so when we're getting our common denominator, the rule is, if it's on one of the denominators, it's got to be on both of them. Okay? So I'm going to say I have to have a 9x squared in my common denominator. So I'm going to write a 9x squared in both of them. Alright? Move over here to this one. I have to have a 3x in both of them. But doesn't this include a 3x in it? So I don't need to put it again, right? Okay? I have to have an x plus 1 in both of them. So let's put an x plus 1 in both of them. Now, when you were a little taught and you were working with fractions, there was always a rule. Whatever you did on the bottom, you had to do on the top, right? So, hold on. Let's, the original one started with a 7 over here. There was a 9x squared. So we didn't change that. But look what's new here that wasn't there originally. So we got to multiply that top by x plus 1. Okay, on the right, there was already an x there, so let me put that. Okay, it already had x plus 1. It had a 3x, but we changed the 3x to a 9x squared. So what did we have to multiply that 3x by to make the 9x squared? So we got to multiply that by 3x. Good job. Okay, so now that's the hard part. We're just doing easy math now. Here's what we're going to do, start cleaning stuff up. So I'm going to have a 7x plus a 7 plus 3x squared all over my common denominator. The only thing that you might see happen here is to put this numerator in standard form. So that 3x squared would go first. So if you want
It'd
to
be
take,
like a quadratic.
yeah. Now Christian did say something that makes a lot of sense. Sometimes this trinomial up here, sometimes you might be able to factor that farther and then do some ninja math like we did the day before yesterday, slice some stuff out if you've got common things on top and bottom. But what multiplies to make 21 and adds to make 7, there's not anything, so that's as far as that can go. All right. Let's try another. Just takes some practicing on this stuff, doesn't it? Come on, page turn. Okay, so we got a subtraction problem, but that doesn't change anything. Still the same. You got to have a common denominator in order to be able to subtract. So to find out what our common denominator is, we don't want to try to just shove the two whole bicycles together. We just want to see what parts are needed. So we need to get a good look at our parts. So we're going to factor the denominators. So on the left side with the 2x minus 2, you can take a GCF of 2 out. So if it was 2x and we took a 2 out, we got an x left. Minus 1, very good, because 2 divided by 2 is 1. Okay, over here I got to multiply to make a positive 3, but add to make a negative 4. What we got for that?
-1, -3.
Very good. Okay, so once I get that and I can see the parts, then I'm going to make me a couple of fractions and get ready to find the common denominator. And remember the rule I told you, if it's on one of your denominators, it's got to be in your common denominator. So I got to have a 2 on both sides. I got to have an x minus 1 on both sides. Okay, so I've got that one taken care of. Jump to the other one. X minus 1, I've already got it. X minus 3, got to include that. So there's your common denominator. Okay, this left side's numerator started off as x plus 2, so I'm going to bring that down. Okay, so this is where we got to be careful, make sure we know what's going on. There was already a 2 there, so I didn't do that new. There was already an x minus 1 there, so I didn't do that new. But there wasn't an x minus 3. So we multiply by an x minus 3 on bottom, you gotta multiply by an x minus 3 on top. Okay, I'm gonna bring down my negative 2x minus 1. I'm gonna go through that same process again. There was not a 2. So if I multiply the 2 on bottom, I gotta multiply the 2 on top. It already had the x minus 1, and it already had the x minus 3. Okay? So what do we have that we can start cleaning up now?
We can ninja math.
No, not yet. Not yet. Can't ninja math because of that subtraction sign. This big thing here. It's got to get it down to, got to be able to condense it down to see if we can do that. But I like that thinking. Don't we have, can't we multiply here and then see if we can subtract any like terms? Okay. So this is going to make x squared minus 3x and plus 2x is a minus 1x minus 6. Now, when I bring down my subtraction sign for this problem right here, that's really tricky because that means we got to subtract everything over here. So I like to put that in parentheses so I don't forget to subtract everything. That's just my personal preference. But then that gets me a negative 4x minus 2. Okay. Now I still am all over that common denominator, but just to save myself some time from writing a bunch of stuff, I'm going to go ahead and see if I can subtract like terms here first. So I got x squared negative x minus negative 4x. No. Negative 1 minus negative 4. Okay, positive 3x, wouldn't it? Yeah. Okay. And now negative 6 minus negative 2. Okay. And now I'm going to write all over that common denominator. Okay, now Tyler, we're going to see if we can do any ninja math. So, is there anything that multiplies to make negative 4, but adds to make positive 3?
Negative 1 and 4.
So that top would be x plus 4 times x minus 1. My common denominator down there. Now, what time is it? Ninja time. So all we got left on the top is x plus 4. All we got left on the bottom is 2 times x minus 3. And you can distribute that 2 if you needed to, if you wanted to. It doesn't make it any better or worse. Just depends on what the choices got. Usually after I do all that much work, I'm just going to stop there. But I mean, that you can do that in your head if you look and see there's not a choice. Oh, that's 2x minus 6, right? On the bottom. Yeah. What y'all think on that? You like that? See, y'all were off learning how to play soccer, and we were in here. That's what happens when y'all miss.
I watched the video.
Good. It was weird because now it's just y'all two that are in the video, and that day it was just Holly was the only one. It was weird. Okay, this last one that we're going to look at is the scariest looking. I got 5 over x plus 4 over 1 over x plus 4.
Huh?
Yeah.
That's not nice.
I know.
So your numerator is a fraction.
Okay, so what they call this is a complex fraction. And I think we would all agree, yeah, that looks pretty complex, doesn't it? So we know that a fraction bar is also a division sign. So what happens here is this is actually going to combine today's stuff with getting a common denominator, adding, subtracting, and the other day stuff when we did Ninja Math with division, because we got a big division problem. But before I can, because I'm gonna do this divided by this, so I'll look up here on my first one and it's just got one denominator, x plus 4. It's a binomial, but it's just one thing, right? Here I've got two denominators. So this is the problem piece. So before I can even think about dividing or anything, I need to get this down to one denominator, so I need to be able to do that addition. So I need a common denominator here. Now, luckily, these are both already factored. We don't have any more parts to take apart. So we can, let me get a new color so we can know I'm just doing this part right here. We can get a common denominator of that, can't we? Because they both got to have an x, and they both got to have an x plus 4. Okay, this one had a 1. X plus 4 is already there, but we multiplied by an x. So we got to make that a 1x on the top, and you don't have to have the 1 times x is just x. This one had a 2. We already had the x, but we got to multiply by x plus 4. So that means that's 2x plus 8, right? And we're adding that to an x. So 2x plus x, 3x plus 8. Okay, so this red piece here is this, over one denominator. So now there's not anything that we can't handle. We got a lot of places to stop along the way. Now where we are is we're doing this divided by this. Dividing fractions is the same as multiplying by the reciprocal. So we're actually going to do this times flip that. Okay? So get some room to work. 5 over x plus 4 times what was it? 3x plus 8. Okay, so your options here. You could multiply straight across the top, straight across the bottom, and then try to reduce. But since there's no plus or minus sign here, just a multiplication, you can simplify. You can ninja. So what time is it? Ninja time. So on the top, I've just got a 5 times an x. And on the bottom, I've just got 3x plus 8. Now, I said this when y'all watched the video, but I just want to emphasize it again because we always love ninja math and get carried away. There's going to be some doofus that's going to want to ninja those x's. Cannot do that because this bottom one's a binomial. You can't pick apart a binomial or a trinomial. It's got to be all of it or nothing. If this was just that, without the plus 8, you could. All right, so that's it. Okay, I was working on my plans yesterday, so the test was coming up sooner than I thought. This is a pretty short unit, so let me tell you all where we are and where we're doing and all that. Tomorrow, we're going to practice the adding and subtracting, have an assignment on that. Then Monday, we'll learn how to solve these equations. And then Tuesday, we'll have a review assignment. Wednesday, on your virtual day, you'll look at your study guide. Thursday, we'll go over the study guide, and Friday, we'll do a test. So a week from tomorrow. Sound like a plan? Tyler's like, it doesn't really matter what I say.